And yeah. Okay, so integration by guessing. And notice it says the kind of integration we're going to do today is going to be called U substitution eventually. Okay. Integration, when we get into these, I don't know, fancier integrals, it depends on what it is. Sometimes, this integration by guessing will become very basic to you, and you'll be like, oh, I see it. I know I need to move my power up one. I know I need to divide by this. I see it. As we get into it more, there'll be some fancier ones that you can't just see as easily, and you do want to think definitely more specifically about U substitution. And so, as we look at this first one, okay, so we're integrating 6 times x plus 1 to the 5th. And so, overall, if we're talking about integrating something to the 5th, what is our answer going to be? It's going to be something to the 6th, right? Okay, so what I would do, first of all, when we talk about U substitution here, what is the inside piece of this that makes life a little more complicated here? And it's that x plus 1. So what I'm actually going to do is I'm going to call that x plus 1 U. Okay. Now, so if this is U to the 5th, what is your guess of what the integral will be? And you're going to tell me U to the 6th, right? Okay, so this is kind of my side work. And again, some of these basic ones, you won't need this side work because you'll be able to see it. Some of the fancier ones, you'll need it, which is why I'm going to kind of do the side work on all of them. So if our guess is U to the 6th, we need to check it. So one thing I'm going to do is I'm going to take the derivative of U to the 6th. What is the derivative of U to the 6th?
6U.
6U to the 5th times the derivative of U. And what do I use as my derivative of U? Well,
It'd be the derivative.
okay, but so when we're just talking about U, though, think differentials here. The derivative of U being du. Okay? Now, with that in mind, okay, what is our U? Because we need to check the derivative of U. Our U is x plus 1. So the other thing I'm going to do here is I need to check the derivative of x plus 1. This one's pretty basic. We'll get into some fancier ones later, and we have more integration by guessing coming up in a few more lessons. So what is the derivative of x plus 1? 1, and officially it's 1 dx. Now, what we really have to do is figure out, okay, do all of our pieces match up? And so the fact of U was x plus 1, yes? And so if you think about this x plus 1, if we put it in both of those places, 6x plus 1 to the 5th. Does that match? And it does, okay? And the fact that that matches, and do I have any extra pieces here? In other words, the derivative of the inside, does that affect anything? Well, in this problem, the derivative of the inside is just 1, so we don't have to worry about that. There's no, and I think I usually call it like compensating for that. So, over here, what are you going to say the integral of 6x plus 1 to the 5th is? If we put in the x plus 1 again, our guess was U to the 6th, except U was actually x plus 1. So I'm going to say x plus 1 to the 6th. And plus C.
Oh, so it's right? Well, mine's plus C.
I don't think anyone said the plus C, but I wasn't judging on that. Here was what I needed to hear, is that you guys were recognizing, okay, this is a 5th power. The integral of a 5th power is a 6th power. Okay, and I know what I'm doing over here to the right almost overcomplicates it. However, there's going to be ones you kind of need this process for right now. Okay, check yourself, right? Does it make sense if I take the derivative here? The derivative of something to the 6th? bring the 6 out front, subtract 1 from the power, and then it's times the derivative of x, but the derivative of x is just, or times the derivative of x plus 1, excuse me, which is just 1, and so that matches up. Okay? Okay, looking at example 2. I'm going to use that whole u thing again. Okay? What do you see? I don't know which one I want to ask. What do you want to be u? Or what do you see as the overall function that we're trying to integrate? Like, what kind of guess are you going to have? Okay.
Yeah, I see the sine, 7 sine to the 6th, which will end up being sine to the 7th of t, right? We don't have to multiply by the derivative of something else, right?
Okay. So what, and this is what I need to see, is you guys are seeing that 7 something to the 6th, right? And that's what I need you guys to be seeing. I know the cosine's throwing some of you off right now, but keep in mind, we're going to have to think chain rule later, right? If we have something raised to the 6th and we were taking the derivative, we would then have to multiply by the derivative of the inside. So when we're integrating, we're going to have the same type issue. It's kind of, I don't know, reverse chain rule. I don't know what you want to call it, but so that is what, what we can kind of think of this is 7u to the 6th. And that means that my u value, my u is going to be the sine. So what is your guess? Just don't worry about the cosine t dt right now, okay? If this is 7u to the 6th, what is your guess for the integral of 7u to the 6th? U to the 7th. So what I'm going to do here is I'm going to take u to the 7th, and I'm going to take the derivative of u to the 7th. And what is the derivative of u to the 7th? 7u to the 6th, right? Now, what did u stand for, though? That is sine t, right? That u right there that we're talking about is standing for sine t. Oh, I forgot something rather important. What's the derivative of u to the 7th? 7u to the 6th times the derivative of u, which is represented as du. That's incredibly important. I can't leave that piece off. Okay? Which means, what do I need to find? I need to find the derivative of u. So, and what is u? I'm going to be picky and say sine t. Okay? And so what we're doing here, so realize, when I say the derivative of sine t, what I'm doing is the derivative of u. So I'm trying to find here the fact that when I say the derivative of u, that's what I'm trying to find right here. And what did you say the derivative of sine t is? Cosine t times the derivative of t, which I say as dt. Well, what about this cosine t? It is the derivative of sine, which is the derivative of u. So what we have here is if you think in terms of u, we are integrating 7u to the 6th du. That's an integral you can do piece of cake, right? Integral of 7u to the 6th du. That's u to the 7th. But we always want to check and make sure the pieces work out. And that's what some of this other stuff is. And you can kind of tweak, as you figure out ways that you want to do this, tweak it and make your own, because this is a hard one for me to teach. Just hard for me to put it down. Like, how do I put it down for you guys to see it? Okay. So, and here's the catch. Did this match up? Du, derivative of u, cosine t, right? Okay, so what is my answer? If my guess was u to the 7th, except what is u?
Sine.
Sine. So what's my answer?
Sine to the 7th t.
So if our guess was sine to the 7th, or u to the 7th, we're going to say sine to the 7th t. No one?
Plus
And Maddie probably can't even see what I'm writing on the board. At that particular moment, because I was standing right smack dab in front of the board.
you just stopped, and I was like, oh, she's waiting.
I'm waiting, and what was I waiting on? Now, think, does this make sense? Okay. The derivative of something to the 7th. The derivative of something to the 7th is 7 times something raised to the 6th, which is this part, right? Times the derivative of something. What's the derivative of sine? Cosine. Okay? And so that's how we can kind of look backwards and check. I haven't sold everybody. Some of you are sold, some of you are saying no. I'm watching faces. And some of you I'm not sure about. But some of you are sold, some of you are not there.
Because it makes sense, because if you take the derivative of sine 7t plus anything, you'll get 7 sine to the 6th t cosine t. Because it's the same thing as doing the chain rule.
Right, and that's what, when you integrate something, to check yourself, you can do the derivative on your answer to work yourself backwards. And so that's what I'm trying to say here, is this is something to the 7th. If I'm doing the derivative of x to the 7th, well, the derivative of x to the 7th is 7x to the 6th, right? Times the derivative of the inside. In this case, it was x. But in this case over here, it is sine. And so the derivative of sine being the extra cosine thrown on there. And you'll learn real quick, when you see those sine cosines next to each other, you know you're either integrating sine or cosine. You just have to figure out which one's the main one and go from there. Okay? I'm trying to think. I was trying to think if there's a different way I wanted to write the next one. Okay. Are we ready to try the next one at least, though? Now, probably smart thing is to rewrite. In that, if I rewrite, then what am I saying? Why am I saying to rewrite?
The square root, so it's like 3 halves times x plus 7 to the 1/2.
And then dx. Okay? Because you guys know, at this point, we don't integrate square roots, we integrate powers. So, you kind of have to have maybe you don't need that visual, but some of you definitely need that visual of, okay, this is something to the 1/2. Okay. Two questions here, and I don't know which we want to answer first. What is your u? What is the inside that we want to make u? Let me start with that.
X plus 7.
Can you see that? Because it's that x plus 7th is something to the power. So if you want to think, and I'm going to write it over here this time, u is x plus 7. Okay? Now, with that in mind, so what are we integrating? We're integrating something to the 1/2. So what's my guess? What's the integral of something to the 1/2?
Something to the 3 halves.
Something to the 3 halves, because you add 1, yes? So what I'm going to have us do is we're going to take the derivative of u to the 3 halves. So that is basically, u to the 3 halves right there is our guess. Just we don't have the x plus 7 in. So if you will, like this right here, that's your guess is what we're putting in there. Okay? Our guess is that this answer is going to be whatever u is raised to the 3 halves. So x plus 7 to the 3 halves. But I don't want to just assume. I want to make sure all the pieces go together. So what is the derivative of u to the 3 halves? 3/2 u to the 1/2 times the derivative of u. Which means, what do I have to check at this point? I need to check and see what the derivative of u is. And what is u?
X plus 7.
X plus 7. So what is the derivative of x plus 7? Derivative of x is just 1. So officially that is 1 dx. So realize right here, this is du. The derivative, what I did right here is the derivative of x plus 7. Okay, that's du. So 3/2 u to the 1/2. Do we have that right there? 3/2 u to the 1/2. And then du. What is du equal to? Well, in this case, it's just equal to dx, essentially. And so do all my pieces match up, and are they covered? They are. That's the nice part about today. Everything will be taken care of.
Now, in the future.
So we're into my next guessing. I don't think we guess again until January, honestly.
I have a question though. So for like
Yeah,
what we're doing
56.
right now, do we have to like justify it? Like, is that going to be like when we take the test? Are you gonna want us to do like the D to the 3/2?
I don't think so.
I know the answer.
You're seeing them.
Yeah.
Yeah, and I think just more than anything, while I'm trying to show the pieces, and I know it's extra confusing right now, is because when we get to lesson 56, it's more integration by guessing. But guess what? There's extra pieces that we have to figure out what to do with. Okay? And so that's, I'm just trying to get you guys to think that way. Okay? Okay, so if u to the 3/2 was my guess, maybe I have a different way I should try writing this out. I'm looking at how I wrote it out in 56. Maybe that would be better. Anyways, what are you thinking the answer is? Do we know that much?
X plus 7 to the 3/2 plus c.
Because my guess was that we were going to integrate and it was going to be u to the 3/2, but u is x plus 7. So I'm going to say x plus 7 to the 3/2 plus c. And realize that's 3/2. That 3, there we go. That's a better 3. 3 wasn't looking very 3-ish. And again, always feel free to check yourself, right? Sorry, I'm looking real quick to see how I ended up writing it out. Maybe that would be a better way to write it out. Or not. Okay, moving on. Notice they're getting a little more complicated as we go down the page, aren't they? Let's see. Did you rewrite this one out a different way? Because again, we don't integrate powers. Nope. Rewind. We don't integrate radicals or square roots. We integrate powers. So, totally said that wrong. When I rewrite this, what do you see?
It would be 3x squared times x to the 3rd plus 4 to the negative 1/2 times the x over 2. Or do you have to bring the 2 up with it?
The 2 does not come up with it. The 2 is just a number. It stays in the denominator. But I would keep the 2 with the 3 because it's a constant. And so I would just think of the fraction as, or the 3/2 being the constant out front, or the fraction out front. So then 3/2, we can put, I don't know, where do I usually put the x squared? Do I leave it right there, or do I put it at the end? Oh, well, actually, what did I do? Interesting. Okay, maybe I want to rewind what I just said. Oh. Okay, so, it's one of those things. Eventually, yes, we'll just think 3 halves. I actually did keep, okay, so what I did, when you bring that x cubed plus 4 up, it becomes x cubed plus 4 to the negative 1/2. I kept that 2 in front of it, but that 2 is in the denominator, right? So it's, don't think 2, just think what is 2 in the denominator. That makes it 1/2. So I thought of it as 1/2 x cubed plus 4 to the negative 1/2, and then at the end I put the 3x squared dx. And I think I did that just to help you guys see how the rest of it works out. So with that in mind, what would you say u is? Because u is the inside piece of something raised to the power, yes? So now, okay, we've got that set aside that u is x cubed plus 4. What's your guess? If this is something or u to the negative 1/2, can you guess the integral?
That.
Okay, to the positive 1/2. So I'm going to use as my guess u to the positive 1/2. Okay, now what do I have to do to check all of this? We're going to take the derivative. The derivative of u to the 1/2 is 1/2 u to the negative 1/2 times du, the derivative of u. And this is where we have to check du, yes? So if I'm checking du, well, what is u? X cubed plus 4, right? So if I do the derivative of x cubed plus 4, what is the derivative of x cubed plus 4? 3x squared dx. Okay. Now, are all the pieces accounted for? One half x cubed plus 4 to the negative 1/2. Does that match up right there? And then we're supposed to have du. But what is du? 3x squared dx. Does that match up? It does. All the pieces are magically working out today. Okay? Huh? Magically. Okay, so what's our answer? Our guess was u to the 1/2, except u was not as big of a gap that time. You guys remember the plus c better. I didn't get to it and have to wait, so. Okay. Moving along. Integrating 8x e to the 4x squared dx. Thoughts on what it is that we're integrating? What's our main function?
Well,
or thoughts on what you want u to be? We could go either way. They kind of go hand in hand.
the beautiful thing about the e to the 4x squared is just that since we integrated an e, or derivative of e, it's just going to be the same thing, right? So we could probably keep that as u and integrate the x term.
We don't want the whole thing to be u.
Just e to the x.
Just
e to the u, and then 4x squared is going to be u.
right. So what we're thinking here is our u is the exponent. And the reason being, as you said, the beautiful thing about e to some power is when we integrate e to some power, or take the derivative of e to some power, it's still e to said power. Okay, so we are going to use u as 4x squared. And then realizing it's e to some power, right? So what's your guess? E to the u, right? Because the integral of e to some power is e to some power. So that's kind of my guess there. Now, as I take the derivative to check this all out, well, this one's a piece of cake. The derivative of e to the u is e to the u du. The important part here is checking du. So now, what is u? U is 4x squared. So that right there, we're trying to check. This is du that I'm finding right here. And what is the derivative of 4x squared? 8x dx. So notice e to the u was our guess, right? Well, there's e to the 4x squared. What else do we have here? 8x dx, which happens to match up. Only life continued to be this good. Right? Okay, so what's my answer?
8x. Yeah.
Yes. E to the 4x squared plus c. And again, check it. What's the derivative of e to the 4x squared? E to the 4x squared times the derivative of 4x squared, and the derivative of 4x squared is 8x.
So honestly, it's a lot more like the chain than it is the substitution.
It's integration chain rule is what it is, you know? Which, the thing is, chain rule is officially a thing with the derivative. With integration, chain rule is not a thing. There's not an official backwards
Yeah, it's just all about working backwards.
chain rule. Yeah, it's working backwards and being able to see it, which just takes practice. Okay. Integral of 20x, 2x squared plus 4 to the 4th, dx. Okay. Well, what can you tell me?
U is 2x squared plus 4.
Do you agree with where he's starting us? He's looking right here at that being our insides. And so u of 2x squared plus 4. Okay. So what is our guess? Going the wrong way. If it's currently something to the 4th, we're going to guess something to the
Still
5th.
going the wrong way.
So since our u value is being raised to the 4th, I'm guessing something to the 5th. What is the derivative of u to the 5th? 5u to the 4th du. And then we need to figure out what du is, so we're doing the derivative of 2x squared plus 4. What's the derivative of 2x squared plus 4? 4x dx. Now, does this one work out? So keep in mind, du, this was right here, right, doing the the derivative of u. So 5u to the fourth. Do I have a 5u to the fourth there?
Yes, it's just multiplied by 4.
Okay. So what is important to recognize about 20? 20 is what you've got to realize is 4 times 5. Okay? That's the connection that's there. And so, and I guess, it's 4 times 5. I think I'm going to say this slightly different. I'm going to say 5 times 4 because then I can put the x right after the 4. And that makes it even more obvious if you hadn't already figured it out. So, let's see. Here is our 2x plus 4 to the fourth. That's u to the fourth, right? And then we've got the 5 that goes with it. And then what is du supposed to be? 4x dx. Are all my pieces accounted for? And that's the key, to make sure everything's accounted for. So if my guess was u to the fifth, what's my answer? 2x squared plus 4 raised to the fifth plus c. Okay. How much or how little you write on these is up to you. If you have one and you see it and you don't really need to write anything out, I mean, this is something, give us a little bit. I won't be really writing anything out. I might talk about it when we do it within a problem, but I don't really be writing anything out. Okay, so, okay, questions? Have I kind of got everyone with me now? At least a little bit?
A little bit more.
Yeah.
I'm not sure. We'll
Okay.
see how the homework.
It's easier to just kind of look at it. Yeah,
I
think
agree.
Looking at it is
Which is part of why I struggle so much to teach this, because it's one of those things that I just see it. And that's, I can't just do that as a math teacher, though. I can't just say, oh, well, I can't teach it. I just see it. That's not, my job is to make it, find a way to explain it.
Just
So.
imagine if the first time we got taught addition, 2 plus 2 is 4. Why is it 4, Mrs. Math Teacher? Because I see it.
Because it just is, I know.